Hi, my name is Alan, and I am a high school student in Monaco. So today I'm gonna present to you my project, Icarus. Icarus is a rocket that went at 500 meters above the ground the 1st October 2022. Its purpose was to pass the L1 Tripoli Certification. This project is the beginning of a long journey. Indeed, my dream is to send people to Mars. Dive in which material I use to build this rocket.
So okay, let's start with the body tube. So the body tube are 8 centimeters diameter cardboard, painted with unusual color. So for this project I decided to make the rocket flashy. So for the lower tube I use a red spray can, and for the upper tube I used a gold spray can. So now talking about the fins. There are 3 fins on this rocket, made out of PLA with a 3D printer. So those fins go through the body tube to be glued in the 38 motor tube with epoxy. So was it a good idea to 3D printing the fins? So actually the response can be debated. So during the flight, the fins were a little wiggly. This is caused by the elasticity of the fins. So the fins are made of PLA, and the PLA is very elastic. So the bulkhead is also made out of PLA and retains the parachute.
So now let's dive in the CAD of the rocket.
Okay guys, let's look at the CAD. So starting off by the top of the rocket, we can see the nose cone. So it's a pretty normal ogive shape. So this ogive is made by me, so I 3D printed this ogive, and so it fits in this 80 millimeters tube by screwing 4 screws, and that's it. So we have down here the CAD model of the computer Geronimo. So those are the supports that help fits the computer into the rocket. You have to screw 8 screws. Oh, there's a missing part here. So the computer is placed into the support by screwing those 4 screws, and then this whole stack is placed into the rocket by 4 screws. So here is not modeled, but actually there is a trap here, an arm switch to activate the rocket. Into the onboard computer video, I will show you the arm switch right here. Going down, there is this coupler, pretty basic, is epoxified in for this part, and it's slide in this lower part of the tube. So this is a bulkhead, and it keeps the upper part attached with the parachute. So I hide this lower tube. So actually here we are gonna put a high bolt screwed in this bulkhead and epoxified, and then going down we can see this lower tube, so 80 millimeters interior and 84 millimeters exterior in diameter, and this is the model representation of the parachute. So yeah, we're gonna see in the recovery system video that this parachute is a 120 centimeters diameter parachute, and it helps a lot to slow down the rocket. Near the parachute we can find the camera, the run cam camera. So those are the 2 supports that keeps the camera on the rocket. So actually those supports are made of PLA with 3D printed. So I used a lot of 3D printing in this rocket. So this support is screwed in into the lower tube near the parachute. I have to admit this is not the best idea I had. Indeed, the parachute could have interfered with the screws. Fortunately, it didn't happen. But you know, in rocketry, you have to be careful of all the details. So this cameras goes down like this, and then the upper support goes in with 5 screws, and the camera is placed. At the bottom of the rocket we can find the motor section and the fins. So talking about the fins, they're made of PLA, and I have to admit this is not a good idea. So the thickness of those fins is 3 millimeters. This is not enough. In the next rocket I will probably change the material or design the fins better. So continuing here, we can see the 2 centering ring with the motor tube. So the centering ring are made of PLA once again, and so this is a pretty basic rocketry motor tube you can find on the internet. This is 38 millimeters, so it's made for 38 millimeters motors. Here is the retainer made in PLA, and I designed it, and I have to say this solution worked pretty much. You can find those retainers for $20 on the internet when you can design them, and the result is the same.
So that's it for the cat. So now, what I would do better next time? I think I would maybe change material for the fins, or trying to find a way to make the fins stronger. Another thing I will change, maybe the tube. Tube were suboptimal. They were not strong enough. Next time, maybe I will take tubes with a larger thickness, or maybe some fiberglass. So finally, I will try to avoid putting too much screws into the rocket. So that's it for today. So next video we're going to talk about avionics. So thank you very much for listening, and I will see you in the next video.